Okay, there is one doubt. Okay, so let's see his doubt. Okay, anyone else also having, if anyone else is also having the doubt, please send your doubts in the chat section. You can send your doubts if anyone is having any doubts, so that we can start their solutions. Okay, let's see. So I think now almost everyone has joined. We can continue now. Okay, so can you see the question? The question says refractive index of diamond with respect to glass is 1.6. Okay, and absolute refractive index of glass is 1.5. Find out the absolute refractive index of diamond. Okay, see there is very good. There is a formula also, direct formula also to compute this. But I will not tell you the formula directly. You can either use the direct formula, or if you do not know the formula, go step by step. But there are some students who understand by the formula, for whom it is easy to remember the formula, and some of you may find it to go step by step. Okay, so all of you please keep your camera on, and let's see how it works step by step first. Okay, so you see, it's given. First, read the question. Refractive index of diamond with respect to glass. Okay, so you make here two medium. The first medium I'm making as glass, and the second medium I'm making as diamond. Why it's like this? This I write as glass, and this one diamond. Why I took diamond below? Can anyone tell me why I took diamond below glass? Why not diamond above and glass below?
So because they said refractive index of diamond, and refractive index is always calculated with the for the medium that has the refracted ray.
Yeah, the medium that has the refracted ray, we compute the refractive index for that medium. So therefore, if I draw it like this, if I keep the diamond below, so then the refractive index will be, then we can compute the refractive index of it. Diamond. Then only we can compute the refractive index of diamond with respect to this. Okay, see, so how it happens now. Now consider some ray coming from air. So on the top we have air. Here we have air. Okay, so how can I compute? Suppose I want the, let's say the air travels with the speed c in, light travels with speed c in air, with some speed vg in glass, and some speed vd in diamond. Right? So if I want to find out the refractive index, let us say I find out refractive index of glass with respect to air, that we also call as the absolute refractive index. So what formula will this be?
Refractive index of glass by the refractive index of air.
Good evening, sir. I came late. What's up to be?
So we are discussing this doubt. Okay. See, the refractive index of glass with respect to air, we can compute this by the formula C by Vg. This was the formula which we used. Speed of light in air upon speed of light in medium. This is the refractive index of glass. Similarly, if I compute the refractive index of diamond with respect to glass, let's see, refractive index of diamond with respect to glass. So I can find out this as Vg divided by Vd. Are you getting? So there is a very short, either you can go step by step or I will tell you the shortcut also that you can utilize. Okay. The shortcut will be later on. First we see this one. The refractive index of these two are given. So diamond is given, which we know as 1.6. So this we can put here, refractive index of diamond with respect to glass. We put here 1.6 will be equal to Vg divided by Vd. And see, from the question, we need to compute this one. Make this equation 1, make this equation 2, and divide both the equations, you will get the answer. Divide both the equations. Refractive index of glass with respect to air is equal to C by Vg. Dividing this by 1.6 equal Vg. Oh no. We need to reciprocate it so that Vg should get cancelled. Oh, sorry. Here, here it will. I have written it wrong. It should be Vd by Vg, right? So Vg by Vd only. So but first reciprocate it and then divide so that Vg and Vg should get cancelled. We want this to be cancelled, or you can say, so we are supposed to find out the absolute refractive index of diamond. We need to find out. Okay, so divide these two, then what you will get? You will get here Vg by Vd, which we do not want. Actually, if I want to find out, my aim is finding out the refractive index of diamond with respect to air. So I want to find C by Vd. Okay. So C by Vd I can obtain if I divide these two, but Vg should get cancelled, then I will be getting C by Vd. So first reciprocate it and then obtain. Reciprocate and then divide. If you reciprocate it, it would become 1 over 1.6, and here it will become Vd by Vg. And now if you divide, you get here n into 1.6 will be equal to C by Vg divided by Vd by Vg. So this Vg and Vg gets cancelled. You have C by Vd, which is the refractive index of diamond with respect to air. Okay. And a refractive index of glass with respect to air is already given 1.5. So put here 1.5 multiply 1.6. You will get your answer as the refractive index.
Sir, instead of using the speed formula, is it
Yeah,
okay
we can.
in the exam? Can we just directly put relative refractive index?
Yeah, you can directly put the formula of the relative refractive index. The formula of the relative refractive index is n21 will be equal to n2 by n1. Okay.
Okay.
Refractive index of medium 2 with respect to 1 is refractive index of medium 2 divided by refractive index of medium 1. This also you can use.
Okay, sir.
Okay. So whatever you are comfortable with. See, with this method, if you practice this method, so you need not remember the formula. If you remember the formula, so you need not worry about this. You can directly get this in one step.
Can you do it once, like N2 1 and N?
Okay. So what is N2 and what is N1 then?
The glass will be medium 1, and then medium 2 will be diamond.
Okay, and what is this N21?
Refractive index of medium 2 with respect to medium 1.
Okay, see. So this is your medium 1, medium 2, and I want to find out refractive index of medium 2 with respect to 1. See, very carefully, the second method, you will find it very easy. See, again, you take the 3 medium. So first of all, this is your air. Then you have medium 1, medium 2. Okay. So relative refractive index, that means the refractive index of medium 2 with respect to 1. We write it as something like this. N21, refractive index of 2 with respect to 1 will be equal to N2 by N1. Right. So here relative refractive index of diamond is given. Relative refractive index of diamond with respect to glass, that is given as 1.6. It will be equal to N2. Then the value of N2 is the refractive index of diamond which we have been asked, and N1 is the refractive index of glass, that is given as 1.5. So just use this, you get 1.6 multiply 1.5, that will be your N2. Okay, so this is just a one-step solution if you use the formula of relative refractive index. Got this? So shall we move ahead now?
Yes, sir.
So multiply this, see what is the answer we are getting by multiplying?
2.4, sir.
2.4, okay.
Sir, but in textbook, N21 is like speed of light in medium 1 by speed of light in medium 2, right? That is different.
How it has been written?
N21 is equals to refractive index of medium 2 with respect to medium 1.
Okay. So see how they read. How is the read statement written below?
Uh, the refractive index of medium 2 with respect to medium 1 is given by the ratio of the speed of light in medium 1 and speed of light in medium 2. It is
Yes.
represented by N21.
Yeah. So see, this is the representation. We can use different representations, right? If I write it like this, N12, and see the reading is same. In the book also they are reading it like how it is read. It is read as refractive index of medium 2 with respect to 1, right? This is written, or this will be written as N2 by N1, right?
Yes, sir.
Okay. So this is how we are reading it. So make your read comfortable. If you remember it N12 or N21, don't remember like that. Remember refractive index of medium 2 with respect to 1 will be equal to N2 by N1.
Yes.
Okay. Any other doubts? No doubt. So shall we start? Okay. So let's see. Today we'll be discussing some of the questions from magnetic effect. Okay. So just I have some questions from magnetic effect. Let's discuss those. Mm, Just wait, I'm sharing it here. We'll be sharing some questions from magnetic effect. Just 1 minute. Okay, see, I got the question now. Okay, so we are going chapter wise. Magnetic effect of electric current. See the statement now. Choose the incorrect statement from the following regarding magnetic lines of field. Everyone should be present. Their cameras should be on. I can ask any one of you. Choose the incorrect statement from the following regarding magnetic field, lines of field. Okay. If you know the answer, provide your answer in the section. If you know the answer. Okay. I got one answer, two answers, right? Let's see. Okay. Amatur Rahman and Tanishka, they have given answers. See, the first statement, the direction of magnetic field at a point is taken to be the direction in which the north pole of a magnetic compass needle points. This is correct. Then second one, magnetic field lines are closed curves. This is also correct. The third one, if magnetic field lines are parallel and equidistant, they represent zero field strength. So, do they represent zero field strength?
No, sir.
If the magnetic field lines are parallel and equidistant, they represent zero field strength. Then the last one is relative strength of magnetic field is shown by the degree of closeness of the field lines. So, which one should be the correct one?
Option C. Option C.
Option C. Why?
Sir, because they represent uniform field strength, not zero field strength.
Okay. So this one, it does not represent a zero field strength. It represents a uniform field strength. Therefore, this C statement is incorrect. Okay. Now see the second one. If the key and these questions, they were answered by Srilasya and Mehak also answered it correctly. See the second one. If you know the answer, just put your message in the chat section in the direct message.
Sir, will you scroll it up a
Okay.
bit?
And the second one.
Yes, sir.
If the okay, you want the diagram, right? If the key in the arrangement figure 13.1 is taken out, is taken out, the circuit is made open and magnetic field lines are drawn over the horizontal plane EBCD. The lines are, what will be the shape of the lines? Suppose if or is there anything that none of the options is correct? Mhm.
I didn't understand the question, so can you explain it?
Okay, this one. See, first of all, the question says if the key in the arrangement is taken out. So here, as you can see, it has a key. The diagram has a key. Okay. If this key is taken out of it, that means the circuit is made open and magnetic field lines are drawn over the horizontal plane ABCD. So you have this plane surface ABCD through which the wire is passing downward. What will be the shape of the magnetic field lines? Okay, just let me make a little bit change here. I think you people are getting confused. So let's see if the key in the arrangement is on. Let's make it is on. Okay. So now can you answer the question? That is the circuit is closed. So what shall be the shape of the magnetic field lines? Yes, anyone? What shall be the shape of the field lines?
So there'll be concentric circles around the conductor, right?
Yeah, it will be concentric circle. So which option should be correct then? Option
Option
A. Okay, so it will be option A. Let's see the third one. A circular loop placed in a plane perpendicular to the plane of paper carries a current when the key is on. I'll give you time. Okay, take some time for this question, but I want answer from everyone. Okay, everyone should send me a direct chat message. A loop placed in a plane perpendicular to the plane of paper carries a current when the key is on. Okay. The current as seen from the points A and B in the plane of paper and on the axis of the loop is anti-clockwise. Anti-clockwise and clockwise respectively. The magnetic field lines, the magnetic field lines from point B to A. The north pole of the resultant magnet is on the face close to. Where will the north pole be? Will it be near this side A or will it be on the side B? Think of this. And I will suggest you to really use your imagine this. Not only just imagine this over here in the diagram. Imagine this loop in front of you in your paper. Then only you can get the answer. So if you observe it from A, the current is anti-clockwise. So from A, you are observing the current is anti-clockwise. Just wait for just 1 minute. Uh, uh, uh. Okay, so I have got some answers. Srilasya's. Okay, let me see. Do I need to explain this? Suppose you are on the side B. Okay, understand this. Suppose you are on the side B over here, and you will observe the current to be clockwise. So if you observe, it will be clockwise. That means for you, the current will be like this. The current is something like this. And the magnetic field lines, the shape of the magnetic field lines will be like this. They will be like point from B to A. So they have also given a very good thing that they have given the direction of the magnetic field lines like this, B to A. So now you can easily see which point will be north, A or B.
Yes, sir.
A or B, or option C or D. There is no meaning of these two options. They are useless. The magnetic poles, they depend on the direction of current and not on the magnitude of the current. So therefore option C and D are false. Okay. See, when we draw a magnet, remember the magnet we draw. Here we draw the north pole, here you draw the south pole, and how you make the field lines. The field lines come out of the north pole and they enter the south pole, right?
Yes, sir.
Okay. So if you observe in this diagram, you can see that the magnetic field lines from and entering towards A. Okay, see. So here the pole from which the magnetic field lines come out is the north pole. So we observe that the magnetic field lines, they appear to come out from the side A, right? So the side A will be the north pole and side B will be the south pole. Okay. So here option A is correct. Any doubt? So in this, I don't think anyone has sent the answer. No one has sent the answer in this question.
Sir, I sent you the answer.
Okay. Now let's see the next question. See here. Fourth question, see. Read it. I'm giving you time. First you read it and then I will explain the answer. Okay. Okay, beta. Okay, I got three answers. Very good. I got three answers this time. Okay, and Amatu Raman, Tanishka, Manan, Trilasya. Okay. So let's see. Four people have answered. Other people might be answering. So let's see the explanation now. For a current in a long straight solenoid N and S poles are created at the two ends. Among the following statements, the correct statement is: the field lines inside the solenoid are in the form of straight lines, which indicate that the magnetic field is the same at all points inside the solenoid. So this is correct. First of all, we are marking those which are correct. So this is also correct. The strong magnetic field produced inside the solenoid can be used to magnetize a piece of magnetic material like soft iron. This is also correct. The pattern of the magnetic field lines associated with the solenoid is different from the pattern of a magnetic field around a bar magnet. This is a wrong one. Okay. The north and south poles exchange when the direction of current through the solenoid is reversed. So this is also correct. So your correct option will be option C. Okay. And let's see who all had marked option C. Okay, everyone had marked option C, just except one person had given option A. Is there anyone? Someone had given option A also, I think. Written 4A. Okay, no issues. So, still, I'm not getting responses from everyone. Manan, Medha Hansini, Rene, you are not
Yes, anyway,
providing any.
answer.
Okay. K. Subhachavik, did you send the answer?
No, sir, answer.
So, post your answer so that I will be able to get whether you are understanding or not. See the fifth question. A uniform magnetic field exists in the plane of paper pointing from left to right. See both of them. Take your time again. Read the question, use the rule and tell the answer. Without using the rule also you can tell the answer. If you just read the options without using your rule, you can tell the answer then. Okay, see. So I will ask someone to explain, and I will ask only that person who has not given the response. If the person has not given the response, I will ask that person only. So Manan and Tanishka, they have responded. Mehak also responded. Hasnita has also given answer. Okay. So the people who are left is K. Subha Charvik. Okay, K. Subha Charvik, let's try to explain this question. All of you turn on your cameras. Mehak, Hasnita, K. Subha Charvik, so that I know you are present. Vedika. Yeah, K. Subha Charvik.
Sir,
Are you okay? Just explain whatever you understand by the question. Okay. First, read out the question, K. Subha Charvik.
a uniform magnetic field extend in the plane of paper point in the
Okay.
left to
So
right
do
as shown in the figure. The
okay.
field.
Do you see the magnetic field lines here?
Yes, sir.
Okay. So what is the direction of the magnetic field lines? Left to
Left
right?
to right. Yes.
Okay. So these are your magnetic field lines. Fine. Then
In the field of electrons and the protons move
move.
as shown.
Okay.
The
So where are the electrons going?
electrons from north to south and south to
Where is the south north? Has the question talked of anywhere north south?
north.
Is there any? No. Then why you are saying north and south? Where are the electrons moving?
Between the magnetic field.
In between the, but in which direction? So this is from top to bottom like this. In the paper, this one is your direction of electrons, the downward direction, and the upward direction is of the proton. Okay. Now, to you, which rule is used to find out the direction of force?
Fleming's left hand rule.
Fleming's left hand rule. Okay. So Rene will tell. Rene, what do the three fingers indicate?
So the thumb indicates the force. The index finger indicates the magnetic field's like direction,
Yeah.
and the middle finger indicates the current's direction.
Okay. So can you find out the force in which the electron will experience? The direction of force which will be experienced by the electron. Mehak, in what direction will the electrons experience the force?
So the electrons will experience the force in the west direction.
Where?
So no, wait, east direction, sir.
See, there is no, unless the question talks about north, south, east, west, right? Do not talk about north, south, east, west. A very simple thing, draw this in your paper. Okay, draw this on your paper and see, they are talking about the plane of paper. Okay, so assume like that. Do not go from the book. Do not go like whatever is given. If you are observing it on the screen like this, so do not go like this. Okay, place it on the paper, and there is no north south. Question is not talking you north and south. Okay, so find out this. So what will be the direction of current? Will this be the same direction or the opposite one? K. Subha Charvik, what will be the direction of current for the electron?
Top to bottom.
Top to bottom or bottom to top?
Top to bottom, I think so.
See, the electron is moving from top to bottom, but the direction of current, it is taken opposite to the direction of motion of electrons. Remember the chapter current. In the chapter current, the current is taken in a direction opposite to the direction of motion of electrons. Okay, so here we will consider the current along this direction. The current due to the electron will be in the upward direction like this. This will be the direction of current. And
Okay.
now if you use your Fleming left hand rule, so using your Fleming left hand rule, your this middle finger should point upward like this. This is my plane of paper, and my magnetic field line should point like this along this. And as you can see, my thumb is pointing into the paper.
Yes.
Did everyone get this? Okay, so electron will experience a force. This will experience a force into the plane of paper. You have to get physical, understand it around your environment into the plane of paper, right? Then what about the proton? Can I say that both the directions are same? Direction of current in here and here, both the directions are current, same.
Sir, can you explain once again?
Okay. See, actually this question, it is a combined form of a question from NCERT, which we discussed in NCERT. Okay. First, let me show that question to you. That question is from NCERT. This is just a version of that. Let me show that question first. Okay, this is known. Okay, fine. Mm, maybe you remember. Okay, let's see. It's not responding right now. It's not opening. I'll show it once it opens. Or if you have your NCERT, open the chapter Magnetic Effects of Electric Current, and you will find a question which is a solved example. Okay, just check out. That is a solved example you have. Okay, see, let's understand over here what it tells. See, the electrons are moving from top to bottom, right? Who was having doubt?
Sir, me, sir, Amatul.
Okay. See, the electrons are moving from top to bottom like this. Since electrons carry negative charge, electrons carry a negative charge, and we have observed that in an electric circuit, if you draw an electric circuit like this, so in an electric circuit, we mark the direction of current from positive towards negative. This is the direction of current we mark. We mark the direction of current from positive to negative, and the electrons travel from negative terminal towards the positive terminal. So actually the current is from positive to negative, but electrons are moving from negative to positive. So that means the direction of motion of electrons is opposite to the direction of current. And if here the question gives you that the electrons are moving from top to bottom, that means the current will be in the opposite direction. It will be from bottom to top. This will be the direction of current due to electrons. Understood this much?
Yes, sir.
Okay.
Yes.
Then the next thing is finding out the direction of force. To find out the direction of force, you have to arrange your two fingers. You have to arrange your forefinger along this direction and the middle finger pointing upward like this. So if you draw like this, open up your left hand, not right. First of all, check it. You are opening your left hand, not the right hand. Okay. So in the left hand, since my middle finger is pointing upward, that is in the direction of current, so it's okay. I only need to rotate my hand so that my forefinger starts pointing in the direction of magnetic field lines. So I rotate my hand something like this. Let's say, are you able to see my fingers, or is it becoming blurred?
Sir, it's blurry, sir, a bit.
Okay, just let me try to check. If I remove the blur, then logo will be removed. Hmm. Okay, fine. Arrange your fingers then. Arrange your fingers accordingly. However, if I try to do that, so the something logo will be removed and I will need to set it again. So arrange your fingers like this, a middle finger pointing upward, forefinger like this, and you see your thumb will point in the inward direction. Okay. So the force experienced will be into the plane of paper. Similarly, if you find out for the proton, they are moving upward and their direction, the direction of current will also be upward since protons are positively charged. So here the direction of current will be the same. and hence they will also experience a force into the plane of paper. So your option A will be correct. Forces both pointing into the plane of paper. See, commercial electric motors do not use. So leave this. You do not have motor in your syllabus. This one is also not in your syllabus. Electromagnetic induction. Right hand rule is also not in your syllabus. Okay. But you can answer this ninth one. See the question 9. See question 9. A constant current flows in a horizontal wire in the plane of the paper from east to west as shown in the figure. Okay. So draw this. First of all, draw this diagram in your notebook and then solve. Draw the diagram in your notebook. Constant current flows in a horizontal wire in the plane of the paper from east to west. And if it is possible, okay, do this on this way only. First, draw this and then find out the direction of magnetic field uh, at a point above the wire.
Sir,
Yes.
sir, can we do this by applying the snow law?
Which law?
Snow, sir, the south or the above the tower.
No, no, no. Okay, after the class, I will be sending out this PDF in the group. Try to solve all the questions from this. Just leave the topics from electromagnetic induction and leave the topics from motor. Rest all you can do. Okay. So anyone got the answer? Amatur Rahman has sent answer. Tanishka has also sent the answer. Okay. So see, I tell you the correct answer is your option A, directly above the wire. So are you finding these questions to be interesting? They are providing you practice for this chapter or not? So for this chapter, make a very good practice of all these questions. Okay. Try to find out this. If okay, anyone who has not understood this question, let's see. See, since the current is pointing, we'll check what it's east to west. Use your right hand, and in your right hand, you should hold the current carrying conductor such that your thumb points in the direction of current. Then, as I can see, since my hands are above the wire, see, I can feel, I feel like the wire is placed in front of me. Okay, if the wire is placed in front of me, So I hold the current carrying conductor like this, and I can see that above the wire, the magnetic field lines, they are from south to north, and below the wire, they are from north to south. So correct option is not A, it's B. I got it as A because for the first time I also use the left hand. If I use the left hand, so I'll be getting the wrong answer. Okay. So use always here to find for the Maxwell rule, use right hand. By using the right hand, you will get the correct answer 9B. So who all had sent the correct answer? Let's see. Okay, Mehak sent A and Ramatu Rahman. Okay. Tanishka only sent B. Okay, Tanishka is correct for this question. So everyone has got the answer? But you need to practice. Just practice these two rules. Now see the 10th question. The strength of the strength of magnetic field inside a long current carrying straight solenoid is. So how it is? More at the ends than at the center, minimum at the middle, same at all the points, found to increase from one end to the other. So we have studied that inside a solenoid, the magnetic fields are same everywhere. They are same at all points, as you find straight lines everywhere in the solenoid. So the answer will be option C. Let's see option 11. To convert and okay, let's leave this generator. The most important safety method used for protecting home appliances from short circuit or overloading is. So which of them do we use for protecting from overloading? Earthing, use of fuse or stabilizers?
Use.
BP.
Fuse. For overloading, it is fuse, not earthing. Okay. Earthing is a safety device against shock, leakage currents. Okay. So can you solve this 13th one? These are short answers. You see, a magnetic compass needle is placed in the plane of paper near point A as shown in figure. In which plane should a straight current carrying conductor be placed so that it passes through the paper and there is no change in the direction of the compass? So in which plane should it be placed so that the compass needle